London's brutalist architecture has created a suffocating concrete trap, but the solution is currently floating right past us on the River Thames. We are using ancient permaculture keyline design to carve invisible corridors through the city's stagnant air, turning dead urban pockets into a massive natural cooling engine. The vast majority of the UK's housing stock, from mid-century blocks to modern developments, was built for a single purpose: to retain winter heat. These structures have almost no built-in mechanisms to release high temperatures during a summer heatwave. In a dense city, this lack of ventilation triggers the urban heat island effect. Materials like concrete and asphalt absorb short-wave solar radiation all day, and because surface water is drained away rather than allowed to evaporate, that heat stays trapped within the urban fabric. The severity of this retention is measurable. Because the city cannot cool off, London's center can remain up to 10 degrees Celsius hotter at night than the surrounding rural areas. By combining winter-optimized architecture with this heat-trapping environment, the city has become a sealed greenhouse. It is a configuration that cannot accommodate projected climate shifts. The standard reaction to this overheating is to install mechanical air conditioning, but in a dense urban grid, this approach creates a catastrophic systemic error. Air conditioning works by extracting indoor heat and dumping it directly into the street. This anthropogenic heat, the exhaust of the cooling process itself, warms the stagnant air even further, worsening the very microclimate that made the AC necessary in the first place. If we continue to rely on this cycle, the data suggests a grim trajectory. Projections show a 5-fold increase in CO2 emissions for city center offices by 2050, driven entirely by the demand for mechanical cooling. Mechanical cooling is not a survival strategy. It is a feedback loop that accelerates the warming of the urban environment. Survival requires a different perspective. Planners must stop treating buildings as isolated, sealed boxes and view the city as a continuous, fluid topographical landscape. We already have a macro-level cooling engine, the River Thames. It provides a massive, continuous source of cold, moving air through the city's heart. In permaculture, keyline design involves routing water across a landscape to maximize its utility. In an urban context, we can apply this to air, carving street layouts to route these laminar river breezes deep into the stagnant urban grid. This relies on the physics of cross-ventilation. By manipulating street width and the orientation of buildings, we can create high and low pressure zones. These zones physically draw the cool river air through the streets, creating a natural suction effect. Manipulating the physical layout of the grid in this way transforms static streets into active ventilation channels, flushing out stored heat every night. However, wind channeling is only half of the solution. To be effective, the air must be actively chilled as it moves through these concrete corridors. Green walls function as thermodynamic tolls. The wall leaf area index, or canopy width, provides physical shading that prevents solar irradiance from baking the concrete facade in the first place. Beyond shading, plants provide cooling through evapotranspiration. They act as natural chillers by releasing water vapor into the wind. Experimental data shows specific taxa like Heuchera micrantha drop a 45 degrees Celsius wall surface down to 21 degrees Celsius, providing a 24-degree passive cooling differential. This high-density foliage provides the thermal mass needed to actively refrigerate river breezes as they penetrate the urban core. This is the fabric-first strategy. We intercept heat with green walls before it enters a structure, and then flush away any remaining warmth using keyline river breezes. By working with the city's natural geography and aerodynamics, rather than fighting them with mechanical systems, we can neutralize the heat island effect and drastically reduce future emissions. Dive deeper into the hidden secrets that shape our reality. Click the subscribe button, activate the bell, and see you in the next scientific investigation into the mechanics of the built environment, only on TEMBODocs.